In this section, we're going to look at how to transform the graph of y is equals to 1 over x. And the first thing is to identify the asymptotes and find ordered points on either side of the vertical asymptote, and that satisfy the equation. And then we plot the points and graph. And here I made a table, and you can see at 0, 1 over 0 is undefined. So there is a break in the graph. And you can see as a result it has two windows, two branches, as you can see here in quadrant 1 and quadrant 3. And let's look at some new vocabulary here. Asymptote. And this is a line or a curve approaches, a line that a curve approaches as it heads towards infinity. And asymptotes are of two types. We have the horizontal one, and these are horizontal lines that the graph of the function approaches. And here, the horizontal, look at this line. It is being approached by this graph, but it's never going to be touched. And the same way we have the vertical asymptote, and these are vertical lines. So here we have a vertical line, it's being approached, and it's never going to be touched by this curve. So here, we're going to look at how to transform the function, and we're going to look at the effect of h and y. We're also going to find the vertical asymptote right here. So the first thing I want you to do is see the original function, y is equals to x in red, and then I'm going to draw the line which is being approached but never touched. So let me try to sketch it here. So this line here. So and it seems the vertical asymptote is the only one which moved here. The horizontal stayed the same. So the graph moved 2 steps to the right. So what do we notice here? The value of h is equals to 2. And if I do x minus 2, if I take the denominator equated to 0, I get x is equals to 2. This is the same as my vertical asymptote. So here, I'm going to write this is the same as the vertical asymptote. So you can see here, x is equals to h gives you the value of the vertical asymptote. And it also helps you, the vertical asymptote helps you to know which side the graph moved. Let's go to the next one. I will start by drawing the asymptote because I can see it here. It's being approached but never touched. And again, it's only the vertical one which moved. So I'm going to do the same thing here. I identify the h. See, h here is equals to -3. And I can also see x plus 3 is equals to 0. So x is equals to -3. And this corresponds with my vertical asymptote. And I can see the same thing. X is equals to h gives me the value of the horizontal vertical asymptote. And it also helps me to see the way the graph moved. See, this one moved left 2 units. And this one moved 2 units to the right. And generally here you can see when h is greater than 0, the graph is moving to the right. When h is less than 0, it moves to the left. Okay, now let's explore the effect of k. And here, let me start by sketching, finding the value of k. So y, so the value of k is 4. K is equals to 4. How do I get the horizontal asymptote? Actually, I get it by using the value of k. And let's see whether it is true. I see here the horizontal asymptote is at 4. The line y is equals to 4. So the horizontal asymptote is given by y is equals to k, which is equals to y is equals to 4. So just by knowing the k value, you know what the horizontal asymptote is. And remember here it moves up 4 units. And you see the graph is moving according to the number of k. So if here h is 0, so it moved up 4, not really 4. I want to give a general situation. It moves up k units. And for this one, the horizontal asymptote is right here. Y is equals to -4. And you can see the horizontal asymptote here. Now I know it's given by k is equals to y is equals to -4. And I can also, remember this is the same as the value of k. K is equals to -4. And I can see when h is less than 0, the graph moves down k units. Okay, now let's move on to, let's do another example. So here we're going to look at the effect of A, and I'm thinking of y is equals to A over x. What happens when A is not 1? So if A is greater than 1, you can see here A is 3, so A here is 3, and you can see the graph is stretched vertically. So this is vertical stretch, and so here we have vertical stretch, and here you can see A is equals to, so here A is equals to 3. I wrote 1 instead of 3. When A is equals to 0.25, so when A is less than 1, you can see its vertical shrink. So this is vertical shrink, and you can see it's being pulled towards the x-axis, and for the vertical stretch it's being pulled upwards towards the y-axis, pulled up. Okay, now you see the effect of A. And now what about when we make the function negative, multiplied by negative? So we can see here the graph is reflected over there. So here this is a reflection on what axis? Actually, see, this is reflection about the origin. We could say about the origin, or we could say we could also say over x-axis, and you could also say it's over y-axis. And why is it all of this? Because the graph, you can see, it's symmetric. So it just looks the same way. So what can we say from what we have seen here? So first of all, in summary, if I'm given y is equals to a x minus h plus k, I can be able to get the vertical asymptote, and and I obtain it by solving the denominator, equating the denominator to 0, and then solving it. So I get x is equals to h. You always have to write it as an equation. And then for the horizontal asymptote is simply given by y is equals to the k value, whatever the k value is. Again, these two, the horizontal asymptote, vertical asymptote, we always write them as equations.